All right, this is a video about on 2.0 preliminaries, but talking about how you simplify how you simplify a radical and decide whether a variable needs an absolute value or not. Okay, so the first thing I do is when I look inside the square root and I think to myself, what are the possible values that a particular variable could be? So let's look at A. A is squared, which means inside the radical, the values of A could be positive or negative. Okay, that's important. So for example, I could have had A be -2, and -2 squared is 4, and that should come out as 2. Remember, no negatives can ever come out of a square root. There could be a negative in front of the square root, but that's not the case here. But you can't have negative numbers coming out of a square root. So when I think about, okay, A could be positive or negative, then I think about, all right, the square root of A squared is A. But because A could be positive or negative, I need to guarantee that it's going to be positive. Because say A was -2. -2 squared is 4, and the square root of 4 is 2. But A originally had been -2, but it can't come out as -2. So it needs to have an absolute value to ensure that indeed it's positive. Actually, let's go to C as well, and then I'll talk about why I'm doing C before I do B. So if I look at C, again, raised to an even exponent, it could be positive or negative, but I think when I think of what the square root of C to the 4th is, well, there's 2 perfect squares in there, so it comes out as C squared. And anything to an even power is automatically going to be positive. So I don't have to force it to be positive by putting an absolute value around it. So it can just be C squared. Now the last thing is B. Now we just said inside I have something squared, A squared, which is going to be positive, C to the 4th, which also is going to be positive. So that means B to the 5th has got to be positive, because if it were negative, I'd be taking a square root of a negative, because a negative number to an odd power would remain negative. So because I'm taking a square root here, I have to be taking a square root of only positive. So this has to only be positive. And then I think of, okay, how many perfect squares are in there? Well, there's 2 pairs, so it comes out as B squared, which by the way makes it positive anyway. And then left inside is a single B, because it didn't have a pair to come out as. Okay, let's kind of do the second one, thinking about the same type of thing. D is to the 11th, and the other 2 are to an even power. And anything to an even power is going to end up being positive when you raise something to an even power, which means D has to only be positive. Again, we can't take a square root of a negative. So because D is only positive, I don't have to worry about an absolute value. So I just have to think about, okay, how many pairs are there? There are 5 pairs, so D to the 5th comes out. There's still a D left inside. E, though, could be positive or negative because it's raised to an even power. And how many pairs do I have? Well, I have 6, which makes it positive anyway, so I don't have to put an absolute value around it. But for F, it's to the 10th. It could also be positive or negative. And then I think about, okay, how many pairs are there? There are 5. Well, something to the 5th power is not guaranteed to be positive, so that's going to need an absolute value around it. So what's coming into play here is, first you're asking yourself, inside the square root, could I input a positive or negative for that given variable? And if it could be either positive or negative, you have to then think about, when you take it out of the square root, depending on the exponent, is it guaranteed to be positive already? Because if something to an even power, it's already positive, so you don't have to worry about forcing it to be positive. But if it's not, you need absolute values around it.